Hi friends, happy e-learning. I hope you are staying safe and healthy and you're ready to learn some calculus. So today we're going to talk about slope fields. So this is an extension of what we talked about in 5.3 about differential equations. And so a slope field is just a pictorial representation of all of the possible solutions to a given differential equation. So remember that a differential equation is just the first derivative of a function, either f prime of x or dy dx. That's the form we were looking at last time. So the solution is f of x or y. But actually there are an infinite number of solutions to a differential equation. Do you remember why that is? So it really has to do with when we solved like y equals f of x and got that as a solution, there was a plus c at the end. And so that could give us infinitely many solutions. Now, if it just looked like this, it could just be shifts of one another. So one function shifted up or down infinitely many times. But remember, we had some problems last time where maybe my constant was underneath a square root, or maybe even in an exponent, something like that. So it's not always just vertical shifts up and down. It's more complex than that. And so what you want to think about, though, is there are infinitely many solutions. Since the constant could be any number. And remember, we figure out that constant based on the initial condition that is given to us. All right. So there are 4 different things you're going to need to be able to do with slope fields on the AP exam. So the first one is to sketch a slope field when given a differential equation. I'm going to abbreviate differential equation as diff-EQ, just differential equation there. Another thing is if you're given a slope field, sketch a particular solution. Using an initial condition. The third thing is to match a slope field to its differential equation. And the last is to match a slope field to a solution of the differential equation. So we're going to practice all 4 of those things. For our next examples, I'm actually going to skip to number 2 first. So if we're given a slope field, draw a particular solution, just so you can kind of see what it looks like. So this is an example of a slope field. And so what's happening here is all of these little lines at the points, those represent the slope of the graph at that point. So if I look at this point, -1, 1, I see that this has a slope of 0, so that means my differential equation is 0 there. And that's because if I were to plug in x equals 1, 1 minus 1 equals 0. So all along this line where x is 1, I'm getting a slope of 0. Here, where x is 2, I'd have a slope of 1 and the slope of -1 when x is 0. So what this is asking us to do is, given a slope field, sketch a solution curve through the given point. So our point is 1, -1. And so we're going to go to that point, our initial condition. We're going to draw a point right there. So we know for sure that that point is on our solution curve. And so what we need to do is draw the rest of the solution curve. And so I'm essentially just going to use these little slope lines to help guide me for the graph. So right here, my slope is going to be 0. So I know I have a horizontal tangent here. Over here, my slope is 1. So I'm essentially just going to kind of sketch between these graphs. I want to make sure that my graph matches up the slope of the lines around it. Then I want to go all the way to the edge of the graph. All right, over to the left. This doesn't have to be perfect. As you go, you just kind of move along with the curve of the lines. So you want them to be parallel as you go. So something like this. That would be my solution curve. So slope field are the lines. This is my solution curve that I'm drawing in. So just draw your initial condition and then let the lines guide you. Let's go back to number 1 now and actually create our own slope field. So if you're asked to create a slope field, you will be given certain points to look at. And so notice all of these coordinates here. Usually on the AP test, there's only about 9 or maybe 12 different points for you to use. You don't have to you won't have this many. But what you can think about is, we're just going to make a table of values here. So we know our derivative is x minus 1. And so what I notice is this is only in terms of x. If you're only in terms of one variable, it's going to make this a lot easier because I can just disregard the y coordinate when I'm calculating. So what I want to do, I'm going to make a table of values. I know that dy dx is x minus 1, so I'm just going to put that in my second column. So the x values I see on my graph are -2, -1, 0, 1, 2. And then I'm just going to subtract 1 from those. So I've got -3, -2, -1, 0, and 1. I always think it's easier to start with your 0 slopes right here, so along x equals 1. And so what I'm going to do is I'm just going to go to the points at x equals 1, just each of these coordinates, and I'm going to draw a little line with a slope of 0. So right here, slope of 0, slope of 0, slope of 0, slope of 0. I like to imagine there's a little person standing at this point, and they're just holding out their arm showing me what the slope looks like. Slope of 0, slope of 0. So all of those. And then slope of 1s are pretty easy to draw as well. So that's just a line at a 45-degree angle. These are all along x equals 2. So I just want to draw these lines that are parallel to each other. These slopes don't have to be perfect. Slope of -1 over at 0. Then after that, slope of -2, -3. So again, these do not have to be perfect, but you should base it off of your other lines. So I know a slope of -2 is going to be negative, but steeper than my slope of -1. So when I draw these lines, I'm just going to make them a little bit steeper than what I had at -1. Try to make them parallel. It's not perfect. It's okay. And then -3. A little bit steeper. Okay? So this actually gives us the slope field that we saw on the other page, so you could look back at example number 2 and see it there. All right. In our second slope field here, notice that this is in terms of x and y. That means we're going to need to consider both the x and the y coordinates when we're sketching our slope field. And so when we make a table of values, there are different ways to do it. I'm just going to make a chart that has x, y, and x minus y in it. So for my x coordinates, again, I have -2, -1, 0, 1, 2. Let's just pick one coordinate of y at a time. So the easiest one is 0. So basically, I'm just going to be going along the x-axis right now. So x minus y is -2 minus 0, -2, then -1, 0, 1, 2. So that means I'm going to draw some slopes over here. So at -2, 0, my slope is -2. maybe a little steeper than that. At -1, my slope is -1, slope of 0, slope of 1, slope of 2. And I can do the same thing for a y-coordinate of 1. So same x-coordinates, I'm just doing my y-coordinate of 1 now. So x minus y, -2 minus 1 is -3, -1 minus 1 is -2, 0 minus 1 is -1, 1 minus 1 is 0, 2 minus 1 is 1. So then I can draw my slopes along here, the line y equals 1. And so again, it might be easier to start with where your 0 slope is. So 0 slope, 1, -1, -2, -3. And as you can see, this could be a little bit tedious. And so an easier way to go about this is to try to notice some patterns. So for example, I know that x minus y is equal to 0 when x is equal to y. So when my x and my y coordinate are the same, then I know I'm going to have a slope of 0. That's going to be along this line, y equals x. And so I already noticed I have my two 0 slopes here. I will also have 0 slopes here, here, and here. Then when the x-coordinate is 1 bigger than the y-coordinate, my slope will be +1. I can see that along this line here. And then I can tell it's going to get steeper as I go. And I can use these other slopes to help me. These are 2 apart, then 3 apart, and 4 apart. Same idea over here. I can see along these lines, those slopes are -1, -2, -3, -4, and -5. So that can help me fill these in. And again, usually on the AP test, there's a smaller number, so it's not going to take you quite as long as it did for me over here to find those slopes, but you can use patterns to help you out. It's not always going to be so nice as that, but sometimes it will be. All right, I'm going to go ahead and cut to another video for the rest of these notes, so see you in a minute.